Now, we're back up here with rectangles. Now, rectangle is a form of a parallelogram. So all that good stuff that we've already talked about, some of it is still going to apply to these rectangles. But it also has some of its own stuff. So let's talk about what happens with a rectangle.
All sides are equal.
Well, not all sides are equal, no.
The two flat sides are equal.
Because in a rectangle, you've only got,
4 sides.
you got 4 sides, but they're not all the same. You can close it. Now, if it's a square, all sides would be equal, but not in a rectangle. First of all, it is a parallelogram, like I just said. With four right angles. Okay, so that's the first thing we got. We've got 4 right angles.
Does that supposed to be a W or an M at the end of parallel?
That's probably not him, but I don't know. That's parallelogram, yes. With 4 right angles. And opposite sides are congruent. I'm just going to use the symbol. Okay, so that's some of the stuff that we still know. It's not slanted or any of this in a rectangle, so we know they're all going to come straight up and down. So that's why they've got 4 right angles. And of course, just like before, the opposite sides are going to be congruent. So we're going to draw this in a minute, and I'm going to show you what's happening. So we've got 4 right angles, and opposite sides are congruent. So those are the 2 things right now that we know about rectangles. Now, we also know that we have diagonals here just like we have diagonals in the parallelograms that we were working with last week. So let's talk a minute about diagonals. So we've got the diagonals bisect each other Okay, so that's kind of what we were talking about last time. They bisect each other. And, of course, opposite angles are congruent. So it's got 2 more in this
Is that
one.
an E or an L?
Where?
Beside the B?
That's supposed to be an I.
An I?
Bisect.
Anyway.
I started for some reason writing an E, and then I realized it's not an E.
So there's 4 of them, Solomon?
Huh?
There's 4 of them?
There's 4 things.
Cool.
So we got there are 4 right angles, the opposite sides are congruent, and then here the diagonals bisect each other, and then opposite angles are congruent. So we've got 4 pieces here. Huh? The opposite sides, top and bottom
The length
sides.
is the same with the
Problem is that you do one side to the other side, the other side not the other side, right? Am I thinking that wrong?
That's problem?
Yeah.
Well, they're just telling you that you've got opposite sides, no matter which ones you're talking about, they're gonna be equal. Okay, so if you're talking about top and bottom, they're gonna be equal. If you're talking about left and right, then they're gonna be equal. Yeah. So opposite sides are automatically gonna be equal, whichever ones you're talking about.
Like, problem line. you're doing a problem with it, the bottom one,
Yeah.
yeah, it's on.
Yeah. So if you're doing a problem and they're talking about top and bottom, then you gotta know that those two are equal. Yes.
So because opposite sides are equal, a square can be a rectangle, but a rectangle can't be a square. Right?
Yes. Okay. So any questions? Now I don't think squares is actually in here. Because we're gonna do some rhombuses and stuff later. It depends on whether we get to it before Thanksgiving or after.
Who's the rhombus?
Rhombus is more like a cat.
That's a cat.
A diamond,
Cat, not a cat.
a right and a diamond, those kind
Yeah,
of shapes.
diamond, something like that, yeah.
I thought it was a cat.
Not a cat. We're not drawing cats.
See my cat on this.
I wish.
Now, so you've got four things here, and of course, all four of these you've seen somewhere before. Now, we've told you that before, if you've got one right angle, you've automatically got four. Okay, there's no in between. We've talked numerous times about opposite sides are congruent. I've told you that the diagonals bisect each other. We had that last week on the quiz. We had it on your homework on the IXL on Friday. And of course, we know opposite angles are congruent. We've seen all this 100 times before. Shouldn't be anything new.
You're right.
So the whole point in this is actually using it over and over and over again. So by the time we take a test on this, there shouldn't be anything that you don't know. It's just different shapes. So now let's look at an actual rectangle. So draw a rectangle on your paper. Doesn't have to be a big one. Can be a small one. As long as it's an actual rectangle. Now go ahead and draw your diagonals too. Now if you want to have different colors here, because I'm going to demonstrate the fact, just like I've done before, that everything should be different. Does anybody want different colors? I mean, I don't care if you do or not. I mean, most of my stuff's in different colors anyway. It's just whether you want it or not. I think two should be fine.
What are you looking for?
Okay. You want them, hurry and grab them while I'm coming by. Doesn't take an hour to grab two.
It was gonna fall.
You got to get whatever handy. You won't hurry up. You got your. You already have one, you just need one more. Okay, so go ahead with your pens and draw your diagonals.
Ain't that the line across?
That's the ones that go from corner to corner. So with your pens, draw your diagonals. Okay, so you should have your diagonals already drawn in your box. So we should have it look like this.
This pen doesn't work, it's not working for me.
Huh?
This pen doesn't work for me.
Is it you or the pen?
This pen.
Both.
No, didn't ask anybody.
Yeah. So it's something else.
Now, what do we know about this?
They're equal,
What's equal?
the sides.
Okay, so the sides are equal.
Yeah.
So, just like before, I know that this one is equal to this one, so again, they have the same mark. So they both get 1 mark, because that means they are equal to each other. So everything that has 1 mark, they're the same. What else is equal?
The, box.
Other side.
The other sides, the left and the right.
They get 2.
So they get 2 marks. So it tells me that opposite sides are equal. So I've already done that. Top and bottom are equal, left and right are equal. So I've marked those with the same amount of pieces, so I know that they are all equal. What else does it tell me? Whatchamacallit?
They bisect each other.
Okay, so it tells me, well, what else does it tell me about my angles?
They're
Right
opposite.
angles are.
I have
all
4 right angles.
Right angles. Yeah.
So it tells me I've got 4 right angles, so that means I'm going to put a what in each corner?
4.
Square.
I'm going to put a box.
Box.
Because remember, that box is what represents
90 degrees.
the right angle, the 90 degrees.
Yeah.
So you need to put a box in each corner. That represents your 90 degrees. So I know opposite sides here are equal. I know that there are 4 right angles. I also know
They're opposite.
what's opposite.
Squares. I mean, the sides.
They're right angles.
Well, we've already got that with the boxes.
The sides are different.
Well, let's go with this. What do I know about the diagonals?
They're the same. They're the same.
What's the same?
Diagonal.
They're cut in half.
They're cut in half. So that means that blue line is cut in half, which means each piece of the blue line is what?
A half.
Is equal. It's a half. So this half is equal to this half. So how can I show that?
Numbers.
By putting 2 lines.
Not
Oh,
2
I
lines,
guess
because
then
I've already got 2.
1 line.
So 3
3
lines.
lines this time.
4.
So this time the blue is going to get 3 lines, because I've already used 1 line, I've already used 2 lines, so now I'm up to 3. So now, since this has 3 marks,
Four.
this has 3 marks,
Oh.
hey, I'm still talking. That tells me that those 2 are equal. So they're both 7, they're both 15, they're both whatever. Now, do the same thing to the pink line that I've got drawn here. So if the blue line was cut in half, then of course this other diagonal is treated the same way. This half is equal to this half. So we're going to put what on it?
4.
4 lines now. So it's got 4 marks. Everything that has the same amount of marks is equal. So I cannot match a 1 with a 3. 1 and 3 are not equal. Okay? So this is what it's telling me. And of course we always know that opposite angles are equal. But now we've got some of these where they're cut in 2 pieces. So we're going to have to kind of deal with this as we get to it. So any questions so far about what it's telling?
Ma'am. So when we underlined the 4 right angles, it means the 4 right boxes.
Yes, because the right angle means the 4 boxes.
Oh.
Okay, any other questions?
No.
Okay, now what we're going to do is actually work with some of these. Okay? So now we're going to draw some, we're going to work with them, which is the same thing that you're going to be doing in your homework.
Is that one right there?
No, there is no rectangles in Excel. I don't know why they skipped over rectangles, but they didn't put any in there. So this time, my rectangle is gonna be going this way. So here's my rectangle now, for the first example. Go ahead and put your diagonals in here. So, you should already have your diagonals. Now, in here, I know that this is P, Q, R, and S. I know that where the two of them meet, in the middle, where the two diagonals meet, is going to be letter T. Now, what they gave me, other than the picture, they gave me that PS equals 180. They gave me that RS equals 200. And my job is to find out what QT equals. This is what it looks like. I can see my clipboard fixing to have to come visit.
Come visit who?
Come visit me.
Huh?
Come visit who?
I don't know, whoever's not paying attention.
I was already got it down, so just look it up.
Now, what do I know right now?
That Q and R are 100.
QMR.
I mean, PS is 180, R
I
is
know
200.
that this side right here,
It's 100.
is 180.
Yeah.
That's what they've already told me. That side right there is 180. That was given to me. What else?
RS is
RS.
200.
They told me that
RS 200.
RS, where's RS?
On the bottom.
SR.
On top.
RS on the bottom.
I think I copied that wrong. That ain't gonna help us.
Miss Sullivan.
That should be PS, not RS. I knew that wasn't gonna work.
Sullivan.
That should be PS.
You have PS.
Yeah.
So that should be PS, not
So
RS.
you already have PS.
I need to go home.
Me too.
Yes.
Are you okay?
No, I'm not.
I need to go home
So
tomorrow.
let's try this again. Let's try PR. Is that better?
Yes.
Okay.
I go home now.
No. If I don't get to go home, you don't get to go home.
That's not fair.
Okay, so now that I have this right, maybe. So PR is where?
Across from each other.
The whole thing.
The whole what?
Line.
The whole
Line.
The whole diagonal. It's this whole diagonal. Right here. So they gave us the side and they gave us the diagonal. Now, what do we know about the whole diagonal?
It's equal.
What do we know about the whole diagonal?
Oh.
Well, half.
It's
Half of it.
200. If the whole thing is 200,
And it's cut
Half of it is 100.
it's cut in half, so I know.
50.
It's 100.
Yeah, you
What?
You was right.
I think you're about off as I am.
Ah, you right.
So this side is 100, and this side is
Another 100.
100.
200.
And if everything's
Okay, so this is 100, and this is 100. Because I took the whole thing, divided it by 2 because it got cut in half.
So if everything's congruent, that would make QT 100.
Yes. So, we know that in a rectangle, every side, okay, every side of our diagonal is basically the same. It's the same shape. So whatever this diagonal is, this diagonal is. They're the same distance. Because it doesn't lean, it doesn't do anything. It stands perfectly straight up, or lays down, however it is, but it's all the same. Because this side is the same as this side, this is the same as this side, so the diagonals are going to be exactly the same. So if these two were 100, these two are also 100. So I didn't have to work anything out.
So Q2 is 100 then.
So it's automatically 100 because I know what my diagonals were.
I'm smart like that.
So as long as I know that the two diagonals should be exactly the same, then I should know that it's going to be exactly the same as the other two. So if one diagonal is 200, the other one should be 200. Okay? Any questions?
How many examples we gone through?
I don't know, we've only done one. Okay, let's look at one where we deal with angles. Now we dealt with sides on that one, diagonals, let's look at angles. So let's try one with angles. So I'm going to use the same kind of rectangle, so I'm going to make it stand up again. So I've got another rectangle. Go ahead and draw your diagonals again, because we're going to need them. Okay, so I've got my diagonals. I know this one, it's the same rectangle, so it's P, Q, R, and S again. T is in the middle here. And I'll see if I can get it right this time.
Are all the numbers the same?
Nope, because we're dealing with angles this time. So we're going to deal with the inside instead of the sides. Okay, so everybody should have it drawn, because it's basically the same one again. Now, this one I basically have two pieces. Shouldn't take us but just a second. So the first one I'm going to give you, that TS is 120. So I want to know what
R does.
PR is.
It's 100.
So that's my first problem. Okay? Now, if I know that TS is 120, how is that going to help me find PR?
That means TQ is also 120.
Okay, so I know that if TS right here is 120, I know that TQ is also 120, which makes that entire line what?
240.
240. So the entire line is 240 because I add this plus this and it gives me the entire line. But if I want PR, which is the other line, what is it? It's 240 because it's the same exact thing as that line. So 120 plus 120
It's 240.
is 240, and both lines are exactly the same. Okay? So if I know one, I can automatically find the other.
That's easy.
So you might have to half one, like we did up there, where we had to divide 200 and put it as 100 and 100, or you may have to add them, like we did here, and get the whole line. Now that's again your diagonal. Let's look at an angle. Okay, so this time I'm going to do it on the same piece. So I'm going to do the measure of angle PRS is 64. So it's 64 degrees. So PRS is 64 degrees. I want to know what the measure of angle SQR is. So I'm telling you what PRS is. So first of all, where is PRS? You go from P to R to S. So they're telling you that it's this little angle right here. So this is PRS right here that I just shaded in blue. And they're telling me that it's 64 degrees. So I know that piece is 64.
It's 32.
Now, I need to know what SQR is. Where is SQR?
Very close.
SQR, they're talking about this angle right here. They want to know this one right here. They want to know the orange one. Now, how is only knowing 64 going to help me?
Divide by 2. You get 32. I'm right there.
No.
Opposite angles of
Like,
Okay, but where's the opposite angle?
It's 64.
that's not an opposite angle.
Just telling me it's 64 is not telling me where an opposite angle is.
Oh, the opposite angle is like,
On the other side.
it's like straight up.
Are you just making stuff up?
I'm using
I think you are.
Nah, that's how I'm using
Okay, let's start here. What do we know about every angle in a rectangle?
it's easy.
Right
It's
at
a
It's
little-
90 degrees. So every one of these is 90 degrees. So if I know this is 90 degrees and this is 64, how do I find that missing piece? 90 minus 64. So if I do 90 minus 64, I know what this piece is over here.
32.
It's 26. Well, you having some trouble today.
-4.
64.
So, to get that one, I did 90 minus 64.
Your calculator hates me.
And I got 26.
Miss Hall, your calculator hates me.
Why would it hate you?
Because it gave me 32 as the answer.
Did you put the number in right?
Nope.
Well, then that's not the calculator's fault. So now, how is that still going to help me?
You divide by 2 right now. I don't even know, Miss Hall.
Okay, well, first of all, I know these two. If I think back about my angles, these are alternate interior angles. So this 64 is actually the same as this 64. And this 26 is the same as this 26. So if you look across, all they do is switch from one corner to the next. So 64 jumped across to this side, 26 jumped across to this side. And it helps if some of you actually write this down.
I put it down.
Huh?
Oh.
Because, I mean, when you run across a problem like this later, what are you going to do? You're not going to holler at Miss Sullivan, because Miss Sullivan did one of these in class.
It's all man. That's 26.
They're all 26 and 64 so far.
That's all the numbers. I think I got it down.
Man, you switch.
Now what?
You divide, right?
Well, there's no dividing.
Why not?
The only time I need to divide is if I'm getting diagonals. I'm not worried about diagonals.
Makes me sad.
Well, you're just gonna have to be sad. You just gonna have to be sad. I'm sorry.
That's all.
Oh, I didn't know that.
Now, where do we go from here? I've got those two. How am I gonna actually get the other two, the ones that I'm actually looking for?
Are they not the same?
Can you divide down?
Same?
If you ask me if we can divide one more time, I'm gonna have to get you.
Get me, what you mean?
Oh, I know, I got people asleep all around you. One there, and I got one over here. My clipboard's gonna be really loving people in a minute.
Well, I love people.
Are they not all the same?
Are they not all the same what?
The angles, are they not all the same?
Well, they are all the same, yes.
So
But you gotta make sure you know where to put it.
64?
So which one is gonna be 64 and which one's gonna be 26?
Huh?
So yes,
So is the bigger one 64 and the small?
what she asked
The bigger one, but.
was, are they not all gonna be 64 and 26? The answer is yes. Because they are all the same, because they're all 90 degrees, and they are all the exact same measurement. Because we're cutting these in pieces, just like they're supposed to be. So, what we need to do is figure out where the pieces go.
I have an idea. What? So you said before that they go opposite to each other. So wouldn't that mean?
Now, I said
that-
they do if they're on the same line here.
Yeah. So what about if when they're in the same box? So wouldn't the 26 be on the other side of the 64? So there would be a 34. I mean a 64 and a 64, and then a 26 and a 26
Okay.
together.
What-
Or would it be the other way?
You gotta have a 26 and a 64 in each corner.
Okay.
They've gotta look just like this in every corner. You can't mix them. So each corner has to have a 26 and a 64.
Okay, so since there's a 24 in like that, yeah,
26.
would that be a 64 on the top?
Not necessarily.
So, wait, so would there be a 64 on the other side, like, on the square in the triangle, not on the top? On like S, in S?
And S.
In S.
Here?
Would that, no,
Here?
not, yes. Would that be a 64?
Yes, that would be a 64.
That's what I said.
I don't know how I got that.
Okay, here's what's happening. If you look at your triangles, okay, these right here are here. These are going to be smaller angles. Okay? You should be able to tell that by looking at your paper. Your angles right here, because you see you've got different angles, different triangles. This one is wider, whereas this one is taller. Does everybody see that? Because it's making two different kinds of triangles. This one is your wider one, which means your angles in here are smaller. Which means that's where your 26 is going to go. They're making the smaller angles, so they're the 26. Whereas this one is taller, okay? that's where your 64s are gonna go. Okay? So you're gonna end up with 2, because remember, both of these are 120. So what kind of triangle does it make if they are both 120?
I mean,
120, a tube's called a triangle. Wait,
Starts with an I.
interesting.
Isosceles.
I couldn't.
So if they are isosceles, because they both have the same measure, these two have to be the same. And the same thing here. If these two are the same, then these two have to be the same.
Is it at all a legitimate way to get it by just thinking, oh hey, that looks like it should be mirrored? Because that's what I did.
It could, but I can't say that you would always go with that. And I don't want you to mess that up by thinking that. The best thing would be to say, okay, these are isosceles same. So if these are the same, then both of these would have to be the same.
So left, right.
If
middle,
these two
top,
are the
bottom,
same,
smaller.
then these two would have to be the same. So if your two diagonals are the same, then the two angles inside there have to be the same. So once I found this one, I automatically knew what this one was. Okay, because that's what happens in an isosceles. Since the diagonals are exactly the same, this is 120, this is 120, this is 120, this is 120, right? So that means whatever's in here is automatically right here. Whatever's right here is automatically right there. Okay, does that make sense? Okay, so that's what's happening. You've got to remember back that, hey, these are identical. So it's making isosceles.
So why did you say no to what I said? Because I was
Probably because I don't know I was lost. That didn't make any sense.
Because it made sense to me, and it was exactly the same way as you.
The wording was confusing.
I'm sorry, I'm confused.
Okay.
So was it right when I originally put down 26?
Well, you may have been right, but what you said to me may not have made any sense, or may not have been right in the way you said it. Let's put it that way. But you may have been right after all. Okay.
This looks like it should be mirrored.
Okay.
My brain saw it as the 20, as since it was 64 across from the 26, wouldn't it be exactly the same every way around? Because if it is opposite from that way and it switches ways, if you were to flip it around, it would be exactly the same.
All I got from that was my half of brain cell is 5.
See, without actually looking at that, I was lost. Because you were saying if this was the same, then, you know, it had to be flipped over here, and I'm going, I'm not looking at it, so I don't know what you're talking about.
Yeah.
Am I sure you want
So without actually seeing what you're talking about, I'm just lost.
Well, I picture things in my brain.
Okay,
You gotta say it
so let's see.
for other people to pick.
Now, those two were fairly easy, or should have been because they had numbers. Well, what happens if I don't give you numbers?
Oh no.
It's the same process, but with letters. So let's try one that has letters.
We all pass out.
Pass out. I'm about to wake up those who are sleeping.
My half a brain cell is about to die. Just the warning.
Well, it helps if I can draw my diagonals correct.
You need a ruler?
Oh, I need to go home.
Alright.
Are you sick?
No, I just need to stop.
I can't go home till you go home, it's all.
Well, I can't go home till y'all go home.
Technically,
I can call my mom right now and leave.
So, you'll just have to ignore the fact that my diagonals don't go where they're supposed to. They're supposed to. So we're going to pretend they go there.
Mine doesn't look that pretty either.
I didn't take an art class.
Mine look prettier.
Okay, so we want to find X.
I still gotta copy it down.
Okay, so here's what we know right now.
Look at this, it's all perfect. 3, 2.
Woo. Now that you've missed several things, would you like to wake up?
Oh, sweet.
I
Well,
was asleep.
I think you was. And you were just one of about 4.
I wasn't asleep, I was awake.
But several decided to wake up before I slammed the clipboard down. What'd you miss? I think that would be problem 2.
School's on fire.
Well, what happened to the bottom part there, problem 2? No, you didn't finish it. Now we're on problem 3 here. No, you didn't miss one thing.
I must have all of these into one problem.
Come on. You didn't write down the bottom pieces.
You just wrote that down.
How did I just write it down when I've been over here?
See,
You've been too busy wondering what I've been doing.
you teleported.
I don't teleport, I can assure you.
Wouldn't that be awesome though?
No.
Yes.
That'd be
Teleport
awesome.
out of here right now.
Well, it'd be awesome for her to teleport, it'd be awesome for us to teleport.
Now, what do we know?
Nothing.
We know nothing. Well, that's great.
How to count one
It's
to
20. We know how to find X.
I hope we know by now that AE is equal to
B, C, or C, E.
CE.
So you said it would equal to me.
So, as before, they have to be equal. So all you gotta do is set those two pieces equal to each other.
So it's 36.
Yes,
So
it's
we
20.
Still gotta solve the equation?
Bro.
We still gotta solve the equation?
You gotta find X.
Find X.
They don't wanna know what it equals, they wanna know what X equals.
They wanna-
So what would you put in here that would make that equal 36 is what they're asking.
Oh.
So you would have to do
So you're doing
2x minus 4 equals 36, so that you could solve it and find out what that would be. So would x have to be 5, would it have to be, 10, would it have to be 6, what would it have to be? That would make that equal 36. Because we know they both equal 36, we just need to know what x equals. Okay, so if we solved it, we would have to add 4, then we would have 2x equals 40, and my pen's dying again. So now if I divide by 2, x is going to equal 20. So if I put 20 in there, of course, 20 times 2 would be 40, so 40 minus 4 would be 36.
Yeah, I said that.
So that's what I would be looking for.